Okay folks, so here's lesson 1 for the Euclidean algorithm. So this is a brand new method that we've not done before, and we should cover it within like 2 lessons. It's a really short topic. Okay, so it says here the Euclidean algorithm is used to find the greatest common divisor, so I'm going to shorten that to GCD now, of 2 positive integers where this cannot be done simply. Okay, so this is actually a skill that we've used since like first year, primary 7 maths maybe. But obviously we're going to make it a lot more difficult. Okay, so feel free to pause this screen here and copy this into your notes jotters. I just thought it'd save me a little bit of time by doing this. Right, what I'll do is I'll go through like an easier sort of example right now, right? So copy this in and I'll just do this example. So find the GCD, so greatest common divisor, of let's say 15 and 24. Okay, so that's the sort of thing that we're going to see. We're going to see 2 numbers and have to work out the greatest common divisor. Now obviously this is easy numbers, small numbers we could do in our head. Think of all numbers that can go into 15 and then think of all the numbers that can go into 24. Then you're looking for the biggest number that goes into both of them. So you can probably look at this. The biggest number that goes into 15 and 24 is 3. Because 3 goes into 15, 3 also goes into 24. Hence the GCD, the greatest common divisor, is going to be 3 for this one. Okay, so that's essentially the skill that we're using here. However, we're going to be seeing much larger numbers here, and that's where we use a technique which is called the Euclidean algorithm. Okay, so it's quite a nice wee topic. Alright, right, let's go on to some advanced higher standard questions. So examples. Okay, so there's 3 examples that I am going to go through with you, and then I'll let you guys practice some yourself. So number 1, find the GCD, so greatest common divisor, of 1147 and 851. Now, unless you are some sort of child genius, if you look at these 2 numbers and you need the biggest number that can go into both of them, you probably, that 99.9% probably cannot do it in your head. Alright, I cannot do it in my head. Okay, and that's where we use a method called the Euclidean algorithm. Okay, so what we do is we start with the largest number, which obviously is the 1147. Okay, and we're going to make this equal to something times then your other number, which is 851, plus something else. Okay, so that's how you lay this out first of all. So I'm just going to actually stick a wee box in here. Something times 851 plus your wee remainder. Okay, so that's how we always get this started. Okay, you are allowed a calculator for this. Okay, so please make sure you've got a calculator with you. It will be extremely difficult to do this without one. Okay, so think of this: 1147. How many 851s can you fit in there? And you probably know that is 1. Okay, now use your calculator. If you were to do 1 times 851 and then take away from 1147, what is your remainder going to be? And I've just got my calculator here. You should get 296. Okay, that's your first line done for the Euclidean algorithm. Okay, now what we do is we try like shorten it each time. Okay, so we are going to take the middle number that's here, so underline that in green pen, and it's like you're shifting that to the left hand side. So that is going to be your new number, which is on your left hand side. Okay, and then this number here, so I'll underline it in pink, the very last number, that was your remainder, that's been shifted along to become the new middle number. Okay, and then it's always something times that, and then you add your remainder at the end. So this bit here, I mean, you don't need to put boxes around it, I'm just doing it to show you. They'll change all the time, just depending on what the numbers are. It's just the middle one gets shifted to become the far left, and then your wee remainder here gets shifted one along. Okay, right, using your calculator, work out how many 296s can fit into 851. So I'm just going to divide them with each other with my calculator. Okay, so I can see it goes in 2.875 times on my calculator. So it's 2 full times, pretty much. Okay, you don't want decimals at all. Right, figure out what your remainder is. So I'm going to type in 851, take away 2 times 296. And your remainder should be 259, just like this. Okay, and then we're going to keep going until we get 0 as our remainder here. Okay, so again, the one in the middle here gets shifted along to become the new one here, and the one at the end gets shifted along, and that's now the new middle one. So I've got 296 equals something times 259 plus something. Okay, so I'm not going to draw in the boxes this time. So if I would just look at this, obviously only one lot of 259 can go in there. So 296 equals 1 times this. And then what's your remainder going to be? I'm using my calculator. Your remainder is 37. Right, so let's keep going, okay, until we get a 0 as your remainder. So 259 goes there. 37 is now in the middle. So it's going to be 259 equals something times 37 plus something. Okay, so again, back to my calculator. Let's work out how many 37s can go into 259. Oh, it goes in exactly, happy days. So it goes in exactly 7 times, and then plus 0 as your remainder. Okay, so remember I said that I kept on going until I got 0 as your remainder. Okay, which means that the last non-zero remainder, so i.e. 37, that's your greatest common divisor. Okay, so I'll write in here. So GCD equals 37. So you need to write that apart because the question's asking for the GCD. So you need to be explicitly clear that you know what the greatest common divisor is, which is that one there. And I'm just going to write in this is the last non-zero remainder. And that's how you always know what the greatest common divisor is. Alright, and if you don't believe me, you can always double check this. You can always divide 37 into the 1147 and divide it into the 851, and that is the biggest number that I can divide into both of them. Alright, it's quite a cool wee technique, isn't it? Right, 2 more questions. Number 2. So find the GCD of, let me stick it in brackets now, 1980, 3696. Okay, so I'll let you copy that down. So greatest common divisor of 1980 and 3696. Again, looking at this, I can see they're both even numbers, so I know that 2 can go into both of them. Is that the highest divisor? I don't know. Alright, so what we're going to do is always start with the bigger number. So the 3696. Okay, so that's the one that goes first. Other number goes in the middle, so it's going to be something times 1980 plus your remainder. Okay, so let's work out what these 2 missing boxes are. So again, back to your calculator. How many 1980s can go into 3696? Just the one. Okay, so it's 1 times this. Let's work out what our remainder is going to be. So I'm going to type in 3696, take away 1 times 1980, and it gives you 1716. Okay, so that's our first line done. That's your first mark, by the way. Right, let's get these shifted across. So the middle one becomes shifted to there, and then the one at the end is now the new middle. So 1980 here, something times 1716 plus something. Okay, so without my calculator, I know that I can only fit one lot of that into your 1980. Let's work out what our remainder is. Right, and I would always recommend just using your calculator here to work this out. Don't be a hero, try and do it in your head. There's no point. You're given a calculator, use it. May as well. Okay, so it's not 0, so I'm going to keep going. So middle number is now going to be my new number on this side. Something times 264 plus something. Okay, so how many lots of 264 can fit into your 1716? 6. Goes in 6 times. Let's work out what the remainder is. So your remainder is 132. Okay, so let's keep going because I've not got a 0 there yet. So that number is now going to be your new number on your left hand side. Something times 132 plus something. Probably do this to a calculator. 132 is exactly half of this. So if I have 2 lots of that, that goes in exactly. And we've now got a 0 here, which is what I want. So the last non-zero remainder, so i.e. the 132, that is your greatest common divisor. And that should get the mark. Alright, so these questions are quite nice to follow a set method. All you need to do is learn the method and that's you, sorted. Okay, right guys, one more question and then you can try some by yourself. Okay, so number 3, so simplify. Got a fraction, so 19,712 over 55,040. So this question's asked a slightly different way. So yeah, you could get a calculator and just start simplifying this. But what I'm looking to do is to get the greatest common divisor. So I can divide that on the top and divide that on the bottom. It's basically asking for your Euclidean algorithm. So hopefully you're starting to get a hang of these questions. Always start with the bigger number at the start. And then it's something times your smaller number, so 19,712 plus something else. So feel free to pause the video at this point if you want to try and get a wee head start with me. Okay, so try it yourself if you want to. Okay, so I'm going to see how many 19,000 blah 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 can fit into this. So I'm just going to divide it. So it goes in 2 times. Let's work out what our remainder should be. So the remainder is 15,616. Okay, so that middle number gets shifted along. It's your new number on the left hand side. So it's going to be something times your remainder plus something. Okay, so I can see just by looking at it, it goes in only 1 time. Again, please use your calculator for this. Don't do this in your head. So your remainder is 4,096. So so the number in the middle, again shifted along your new left number. Okay, so I'm just going to divide these 2 numbers. So it goes in 3 times. Let's work out our remainder. Remainder is 3,328. Again, we're just going to keep going here. So number in the middle gets shifted along. It's 4,096 equals something times 3,328 plus something. So numbers should be getting smaller each time. Okay. So obviously it goes in once just by looking at it. The remainder is 768. This number is what we start with. Okay, so it goes in 4 times. Okay, so I hope you guys have got your calculators out and doing this alongside with me, like at the same time, just so you start practicing the skill of it. The remainder is 256. Number in the middle, something times 256. It's quite therapeutic actually. Oh, happy days. Finished. Goes in exactly 3 times. There we go. Alright, so 0 is your remainder. Alright. Again, finish off the last non-zero, so 256. I'll get my highlighter. That is going to be your greatest common divisor. So it's that point there. And finish off, just write GCD equals 256. Done. Alright. Oh, we're not finished this question yet. Oops, because we had to simplify that fraction. So if I finish it off by writing that fraction and divide like the top and the bottom by 256. So I've got it down here. So if I divide the top by 256 and divide the bottom by 256, that will give me my simplified fraction. So we should get 77 over 215. Okay, so when you go to lesson 2, for the exam questions, this is always the very first part of an exam question, and so it's worth 4 marks. All of this part would be worth 2 marks. So you get 1 mark, your very first line, and then your second mark would be this. Okay, so that's the first half of all the exam questions, and I've done it just in a couple of minutes. Okay, so here are the questions I would like you to try. Okay, so pause the screen at this point, take a wee screenshot. So I want you to find the greatest common divisor of all of these and showing full working. Okay, so I'll reveal the answers in a couple of seconds, but can you pause the screen and try these by yourself? Okay, so here are the answers for all of these. So can you correct your work and then get ready for lesson 2?